Hi, Kendall.
Hi.
How are you doing today?
I'm good. How are you?
Good. All right, shall we start with 20?
Yeah. I tried it on my own, but then I just got confused and erased what I did.
That's fine. So here's a situation where they give us the big angle, 78 degrees,
Mm-hmm.
right? That is NRQ. And then they have two angles that make up NRQ, and one of them is 8x plus 7, and the other is 4x minus 1. So the idea is to see if you can write an equation.
Okay.
What equation would work?
8x plus 7 plus 4x minus 1 equals 78 degrees.
Yeah. Now, I don't need to use parentheses here because that's a plus.
Mm-hmm.
But just to be safe and for clarification, you really probably should do that.
Yeah.
Because sometimes it's going to be a minus. And when that plus is a minus, then the parentheses are really important, the second set of parentheses.
Yeah.
First set is rarely necessary. Only time I ever use the first set is for clarification. Okay, so the very first step is to eliminate the parentheses. And now what?
And then combine like terms.
Correct? So what do we
Okay,
have on the left?
So wouldn't you subtract 4x from 8x, or would you just add them together?
If I'm combining that with that, I'm adding them. There's no
Okay, so that would be
minus signs there.
12x.
Okay, so when I combine the x's, I get 12x. How about when I combine the two numbers on the left side of the equation?
You get 6 plus 6.
Next step of the solution?
Subtract 6 from 78.
And finally, x equals
72.
72 divided by 12. In other words, don't forget the last step. The last step of the equation is always to divide by the coefficient.
Yeah.
So I've got to divide the left side by 12, divide the right side by 12, and I get x equals 6. So I've solved for x, and now they want to know, what do they want to know? They want to know what the M or PRQ, this one right here is. So they want to know what the 4x minus 1 is. What is that if x is equal to 6?
So that would be 4 times 6 minus 1.
So that's equal to 23.
Okay.
That's that angle. Okay, so when you have, these are very, very typical geometry problems. When you have them, the idea is to write an equation with one variable in it, use algebra to solve for that variable, and then go back and plug in what you solved for x, and it'll tell you what this angle is or what this angle is. So it's a similar process with all of it. Here.
Okay.
Let's look at 21. Hold on a moment. Okay, they're telling you that the BD bisects the big angle. Find one of the small angle, or find the big angle.
Okay.
What equation can I write here?
5x plus 2 equals 7x minus 6.
Okay, solve that. Next step.
So then combine like terms, so
Okay.
12x
Hold on.
plus.
If you move one of the x's to the other side, you have to change its sign. In other words, I have 12x. You got 12x because that's a plus 5x and that's a 7x. But they're
Yeah.
on opposite sides of the equal sign.
Mm.
So I either have to move the 7x over there and make it a negative, or I have to move the 5x over to there and make it a negative.
Okay.
Which
So
one
then,
makes the most sense to do?
subtracting 5 from each
Why?
side,
Why?
and then you don't end up with a negative.
You got it. So I'm going
So
to
then,
move the 5x to that side, which is going to give me 2x. And then what am I going to do with the numbers?
and then you're going to add 6 to each side.
Okay, that's going to give me 8. So now when I solve for x, what do I get?
X equals 4.
Right. And then I can plug x equal 4 into each of these to figure out what each one of them is, and then the ABC is twice whatever each one is.
Okay.
Now, this does kind of illustrate an important point in algebra. It works if we do it the other way around. In other words, if I move the 7x over to there, I'm left with 5x minus 7x, so minus 2x. And then if I move the plus 2 to the right, it turns negative. So I have minus 6 minus 2, which is minus 8. Now I solve by dividing both sides by minus 2, and I still get x equal 4. So I get the same answer regardless of which way I do it.
Yeah.
But most people make more mistakes when they have lots of negative signs.
Yeah.
And I ended up with negatives on both sides of the equation here. Well, whenever that's the case, you're usually better off moving your variable to the right and the numbers to the left. Now, if this was a plus, like that, well, now notice that it doesn't matter which way I go. I'm going to have a negative side on one side or the other. In other words, I'm
Yeah.
either going to have minus 2x equals a positive 4, or I'm going to have 2x equals a negative 4. So if this were the problem, it wouldn't matter which way I went. I'm still going to have one negative sign. There's no way to avoid it. It doesn't really matter which way you go. A lot of people are more comfortable if their variable is on the left side of the equation. Well, lose that comfortability, because a lot of times, like the problem we just did, it was far more comfortable if you had the variable on the right side.
Yeah.
If this is the problem, then it doesn't matter. Go ahead and put the variable on the left side. It's just as difficult. You're going to have a negative sign on one side of the equation, regardless of which way you do it. All right. Let's look at 22. What equation can I write here?
8x plus 9 equals 6x plus 17.
Not equals. Do those look like equal angles?
No.
No. If this was a right angle, then yes. In fact, if that was a right angle, I could just say 8x plus 9 equals 90 degrees. But it's not a right angle, and when it's not a right angle, this angle is never equal to that angle. But what is true? what is this angle plus that angle equal to?
This.
In other words, that angle plus that angle equals what? It's equal to the straight angle.
Yeah, so that would be 180.
180, exactly. In other words, these are vertical, or I can't remember the exact term, what they're called, but they're supplementary. Anytime angles are supplementary, as you see down here, it means they add to 180. If two angles are complementary, they add to 90. In other words, if I give you a right triangle, incidentally, your cold sounds better. I can still hear that you have it, but it's a lot better. You sounded terrible the other day.
Yeah, I wasn't feeling too great.
I imagine. So if I have this right triangle, I can say angle 1 plus angle 2 is 90 degrees because the two acute angles in a right triangle are always complementary, because the most basic thing about a triangle is the sum of the three angles adds to 180, no matter whether it's a right triangle or not. In other words, even if I have a triangle like this, the sum of 1 plus 2 plus 3 is 180. So these three angles are supplementary. These two angles are complementary. Okay, solve this equation. First step is to remove the parentheses.
Yeah.
Do I have to do anything when I remove them, or can I just remove them and not change anything?
You can just remove them.
Okay, cool. Now, what's the next step?
Subtract 6. No, wait, you combine like terms.
Okay. So what does that give me on the left side?
So then you get 14. Yeah, it's 14. So you get 14x.
What are the two numbers combined to?
X plus 17. 26.
Equals 180. Next step.
Subtract 26 from itself and then 180.
Okay, 154. And x is equal to 154 divided by 14, which looks to be 11.
Yep.
And now we just plug in 11 for x. And this angle here is 8 times 11 plus 9, which is 88 plus 9. That's 97 degrees. This angle here is 6 times 11 plus 17, which is 66 plus 17. That's 3 degrees. Notice that they are supplementary. They do add to 180. Okay, notice that we have two variables in 23. We have an x and we have a y. Usually when you have two variables, you need two equations. But we might be able to solve for x without using the y part. What equation can I write?
14x plus 4, would it be equal to 16x minus 4?
No, only if that was a right angle, and they don't tell us that it is. But what is true? What was the last problem? In other words, the last problem, they were next to one another, so they added 180.
Yeah.
Okay, that's all you need to do is say 14x plus 4 plus 16x minus 4 equals 180. And
Okay.
notice what's going to happen. We only have one variable there,
Yeah.
x, which means I'm going to be able to solve for it. Okay, once I solve for x, now I can go down to these two equations and say that this angle plus this angle equals 180 also. And then I'll be able to solve for y.
Yeah.
Or I could even say that this angle is equal to this angle, which is true. Those are vertical angles. In other words, whenever you cross two straight lines, angle 1 is equal to angle 2, and angle 3 is equal to angle 4. And you can also say angle 1 plus angle 3 is equal to 180, angle 3 plus 2 is equal to 180, and angle 2 plus 4 equals 180. So the relationship between these four angles here is pretty important. Let's solve this. Next line.
Okay, 14, that would be 30x. 4 plus, the two 4's just cancel each other out, don't they?
Yes.
So then 30x equals 180.
So x equals,
Divide x equals 6.
3 into 18. Okay, now, at this point, I have two choices. I know that 14x plus 4 is equal to 4y minus 8. In other words, this angle is equal to that angle based on vertical angles. And I know what x is, so I can fill in 6 for x. So 14 times 6 plus 4 equals 4y minus 8. Again, I have one equation and only one variable, y, which means I can solve it. And that's probably, I would find this the easier way than saying this plus that equals 180. Let's just make this equal to that.
Okay.
Okay. And then 14 times 6 is 84. Plus 4 equals 4y minus 8. So now I have 88 equals 4y minus 8. Move the 8 over here. Equals 4y. Y equals 24. So now we know what y is. We know that x equals 6 from our first calculation. And that was the problem. Solve for x and solve for y.
Yeah.
Okay. As you can see, algebra is as big a part of geometry as geometry is.
Yeah.
More important. So basically, always are solving geometry problems by trying to write an equation. Just always keep that in mind. So on the next one, what equation can I write? This one down here, 24. If they're supplementary, that means what?
They're equal to 180.
They add to 180.
Yeah.
So what equation can I write?
Negative 4x plus 40 plus x plus 50 equals 180.
And again, I've put parentheses around each of those just for clarification. Because this is a plus, I am not going to need either set of parentheses.
Yeah.
If it was a minus, I would need this set here because the minus would change the sign on that second term. But in this problem, I can just erase the parentheses without changing anything. And now combine variables.
Okay. Since negative, so would it just be 3x?
Positive or negative?
Negative 3x.
Right. That's as important as the answer, is the sign. In other words, I'm combining that with that, which is the same as negative 4 plus 1, and that's negative 3. And then combining the two numbers, they both have plus signs in front of them. And now I get minus 3x equals 90. X equals minus 30 degrees. Or, excuse me, X is not in degrees. X is just a number. Can we have a minus?
No, I don't think you can.
You can't really have a minus angle.
Yeah.
You could have an X that's a minus. In other words, if X was minus 30 here, this angle would just be 20 degrees.
Yeah.
And in fact, it does work. I was misreading it at first. You can have an X that's minus. You just can't have an angle, not at this point. When you get to trig, you can have minus angles. But in geometry, all angles have to be positive, all lengths have to be positive. You can't have a negative length.
Yeah.
Notice what angle A is. The measurement of angle A equals a minus 4 times x, which is minus 30, plus 40. Well, minus 4 times minus 30 is plus. So that becomes that becomes 160. So that's a positive angle. That works, even though x is minus. And then the measurement of angle B is x plus 50. Well, x is a minus 30, so that would be 20 degrees. So both angles come out to be positive, even though x is negative.
Yeah. That's
okay. Notice that both of these 160 and 20 are supplementary. They add to 180. So there's nothing wrong with negative variables. You just don't want negative angles. Okay, if these two angles are complementary, what equation can I write?
2x plus 10 plus negative x plus 55 equals 90.
Again, I'm going to use parentheses in the second angle. And now remove those parentheses. What do I
have? Would it just be 1x? So it would just be x.
Minus x. In other words, I still have this minus sign in front of the x. So if I just remove the parentheses, it's correct, except I have a plus and a minus, which always is a minus.
Okay.
Whenever you have a plus and a minus next to one another like that, it's minus. Okay, and that's equal to 90. And now if I combine everything, I get x plus 65 equals 90, and finally x equal 25. And it's a positive number this time, which means angle A is 2 times 25 plus 10, which is 60 degrees. I don't even need to plug it in over here. I know it must be 30, right? Because they're complementary. Yeah. But also, if I do plug in an x of 25, it's minus 25 plus 55, that gives you 30. You might have left off a problem here.
Oh, I already did those ones.
Okay, should I go to the next page?
Yes, please.
Which is this page here. Okay. This page is using a compass. Now this may be the only difficult thing that's hard to do online.
Yeah.
I haven't found very many things that are any different online than in person. But
Yeah.
using a compass and a straight edge might be one of them. First of all, let's do the easy ones. You know what a compass looks like. Do you have one in front of you?
Yes, I do.
Okay. Let's do 30 first.
Okay.
To do 30, just draw a horizontal line. Put one end of your compass there, put the other end there, and then on the horizontal line, put one end at Y and make your arc. In other words, don't change the measurement of the compass.
Yeah.
And that has to be the same length as WX, because we got this length from putting one end of our compass there and the pencil end there.
Yeah.
Okay, so that's easy to do. Let's see, let's do 31, bisecting an angle. Let me orient it a little bit differently. I'm going to have that angle right there. And if I want to bisect this angle, I put the needle end of my compass there. I draw an arc. Doesn't matter how far out. I can make it a big arc. In other words, I could go out to here, or I could do a little arc. Immaterial. The important thing is that AR is equal to RC.
Yeah.
And that's guaranteed if I use a compass. Because in other words, I don't care how far out I am, I just care that AR equals RC.
Yeah.
Now, to bisect this angle, go put your needle there and draw an arc like that. Don't change the distance on the compass. Put the other needle on point A and draw an arc like that.
Okay.
And then take your straight edge and line it up with either point, and you will make the bisect, right? And draw it very well here. See if I can do it a little bit better. There's the angle that bisects it. So let's see, if I put that there and do the same thing there, it'll cross like that. In other words, you don't need two. The first time I did it, I did the whole arc. You just need the point where those two arcs are going to cross.
Yeah.
Okay? All right. Bisect the segment below, 32. We'll get back to 29 in a second. 32. If I want to bisect a line, a lot of times when you're using a compass and a straight edge, the very first step is to draw a horizontal line. Okay? And if this is my line, in other words, I'm not duplicating that line, I'm just trying to bisect between C and R, make sure that your compass is more than half the distance.
Okay.
Put your needle point on C make an arc like that. Put your needle on R, make another arc like that. Now take your straight edge and connect the two intersecting points, and where that crosses the line, that's the midpoint.
Okay.
Copy the angle below. Well, they don't mean using a protractor. In other words, using your compass. Copy it. Well, what can we do here? Remember, the first step is always to start out with that horizontal line. That's basically going to be my CS.
Yeah.
Put your compass there.
Okay.
Draw an arc there to make sure that CS is the same distance as this CS up here.
Okay.
Now you could put your needle on S, measure this arc, this length, and draw an arc that's going to go like that. I can't draw an arc. But you know basically what it's going to look like. In other words, it would go somewhere like that, right?
Yeah.
In other words, the distance from this point to any point on that arc is the same as the distance from S to U. Okay? Now take your compass and put it on C, and go to U, change its distance. Go back and put your needle on C, mark off that arc, and it's going to cause an intersection with the other arc. That's the point where this line has to go. And now I'm guaranteed that this angle here will equal that angle there.
Okay.
Okay? All right. I guess we'll end it there. And pick up next time.
All right.
Okay.
Thank you.
All right, Kendall. Have a good one. Bye-bye.